Whenever a process tries to access a file, like if it wants to read or write onto the file, then operating system has to do many things, like it has to search for the file and get the information about the file, about where it is located and all, and also it has to see what is the last time access made by the process. For example, if you are trying to read something from the file, let us say if you have already read it and now again you are trying to read it, then the next information from where you have left has to be shown to you, right? And how can the operating system keep track of all this information? It is going to be hectic because many processes will try to open many files, and operating system has to, anytime whenever any process asks it for a file, it has to go through all the directories to search about the file, to search about the information and then get the information. So instead of going through all this painful process, what operating system will try to do is it will try to maintain some tables, right? In these tables it will just keep the frequently asked information, or the open files like this. If some information is going to be used very frequently, it is very useful that you keep it in a place where you can fetch it easily, right? So the same concept has been used in the page tables. If you remember it, the frequently used entries in the page table are actually kept in a special memory, right, the cache. So similarly here also we can do the same thing. So here, whenever a file is open, whenever you want to access a file, if you have the intention to access a file, or either for reading or writing any process, it is supposed to open it. So the first rule is every process is supposed to open the file before it reads it. Then whenever you open a file, operating system is going to create a table. Okay, so let us say you have a process P1. Let's say I'm just writing some few processes P1, P2, P3, right? So whenever P1 tries to open a file, then operating system will create a per process file table. Per process file table. In this per process file table, it will maintain information about what is the file that this particular process wants to open. So whenever this one calls open, then it is going to maintain what is the file that it is going to maintain, right? Let us say the file is ravi.c, okay, something like this. Now this file is going to be opened, so it is going to maintain some more information about the file. So what are the most important information is it has to maintain a pointer, right, file pointer. So this file pointer is going to point into the file about where did we leave reading or writing last time. So again, if you have to access the file, we can resume the operation from the point where you have left it, right? And then along with that, it will even locate the access rights, right? So access rights says whether this process can execute it or only read it or only write it, or can it execute it, read, write, execute. So this information is going to be placed in the per process table. Along with this per process table, which the operating system maintains per process, for every process there is going to be a table like this. Along with this, operating system will also maintain a global table, right? It is open file table. This is global, which means for all the files which are open, it is going to maintain a global table, and for all the files which are opened by a process, it is going to maintain a per process table. So per process table will contain the information which is relevant for a process in order to access the file, and the global file table will contain the information which is relevant for every process in order to access a file, right? Now let us say there is one more process P2 which also wants to open the same file ravi.c. Let us say it is also opening the same file ravi.c. Then it will also maintain in its per process table what is the file pointer, because these two file pointers will be different, right? So the file pointer which is used by P2 might be pointing to a different location, and file pointer which is used by P1 might be pointing to a different location. This depends on which part of the file this one is reading at present, and which part of the file this one is reading at present. Both of them cannot use the same pointer because both of them are not going to read at the same time synchronously, right? And along with that, both the process might have different access rights, right? This information will be provided here. Now, in order to open this file, operating system needs some more information like where the file is located, and the file location does not depend on the process which is opening it, isn't it? That is why the file location information will be located in the global table, right? So let us say this is the entry for ravi.c file, and then file location is going to be present here, and along with that, okay, now file location is going to be present here. So whenever this process wants to read something from this, operating system will first consult the local entry per process page table, and then it will see from which pointer it should continue reading, and then it will see whether it has the access permission to access that, and in case if it is true, then there will be a pointer in this entry which is pointing to this entry. Therefore, operating system will go from here into this entry and then get the location of the file and get into the hard disk using the location, right? And then in the hard disk it knows the location and the file pointer, and then it will get the information whichever you are looking for. Got it? So this particular file table is going to grow depending on the number of files which are currently open, and whenever the file has been closed, you are supposed to delete the entry so that you can make space for other entries, other files, right? But then how can you understand whether everyone has closed it? Let us say if a file is opened by only one process, then of course if it closes it, then you are going to delete the entry here, right? And then can I delete the entry here also? That depends on whether all the other files, all the other processes which have opened this file have closed it or not. So just to make sure that all the processes which have opened a file have closed it, we are going to make a counter, right? So this counter is known as file open count. This is nothing but number of processes which have opened a particular file. Why is it important? Because when all the processes which have opened a file have closed it, then only we are supposed to delete that entry from the global file table and then delete it completely, isn't it? Therefore, we are going to have one more entry here which is called as file open count. So this file open count is going to show us how many files, how many processes have currently opened the file. Initially it will be 2 because 2 of them have opened it. In case if some other process also opens it, then it will be incremented by 3, and whenever any process closes it, this record will be deleted and it will be decremented. Initially it was 2, now it is 1, and later if this process also closes the file, this record will be deleted. Along with that, this will be decremented to 0, and whenever this decrement it gets to 0, it means that no process is actually opening this file, is using this file. All the process have closed it, right? Even if you don't close it, whenever a process terminates, obviously all this is going to be freed up, and even the count is going to be decremented here. So once this count reaches 0, this particular entry will be deleted. The usefulness of this maintaining these tables, open file tables, is just to save time. If you don't have these tables, then every time any process performs an operation on the file, you are supposed to get into the directories and search the entire information, and then search the pointers and maybe access rights and then the file location. It is going to be tedious because you have to get into the hard disk to get that information. If you can store it in terms of some tables in the main memory, it will be faster. Got it? So this is how we save this information on the main memory to make it easier or faster or efficient. Got it? Okay.